Hello students, welcome back to my channel JPPHYSICS. In last lecture we have discussed about the properties of charges from that electrostatics, and now in this lecture we are going to discuss about the Coulombs law of electrostatics. Coulombs law of electrostatics. You remember in 10th standard, you have considered that law of gravitation. What was that law? You remember? What was the statement for that law? Gravitational law. That is, force of attraction present between the two masses. If there are two masses M1 and M2 separated by some distance, that is R, okay? And that force of attraction present between that two masses, it is directly proportional to product of the masses and inversely proportional to square of the distance between them. Directly proportional to product of the masses and inversely proportional to square of the distance between them. This law is about these two masses, any two masses present in the universe, correct? But this law, similar to this law of electrostatics, that is Coulomb's law of electrostatics, it is for charges, any two charges. But in case of charges, what is the fact? That is, charges will be of two types, that is positive charge, negative charge. If we consider two positive or two negative charge, that is like charges, there will be repulsion. And if we consider unlike charges, there will be attraction between them. In this force, that is force of gravitation, that force is only force of attraction. In this case, we are going to see two types of forces, that is force of attraction, and also you can consider the force of repulsion. For like charges, there will be repulsion, and for unlike charges, there will be attraction. We know these properties, that is like charges attract each other, unlike charges attract each other and like charges repel each other. Okay, about that only we are going to see this Coulomb's law of electrostatics. See, what is the statement for this law? There will be question in exam, that is state and explain Coulomb's law of electrostatics. How you are going to write the answer for that? First, you have to write the statement for that law. What is that statement? See, if you consider two charges, I will write here, if there are two charges in place of masses, in case of a law of gravitation, here we are going to consider two charges. And these charges are separated by distance r from each other. Okay, so the force of attraction or repulsion, if these two charges are plus plus or minus minus, positive positive or negative negative, there will be force of repulsion in between them, correct? So force of repulsion, if one is positive, another is negative, that force will be attractive, correct? So what will be the statement for this? The force of attraction or repulsion, force of attraction or repulsion present between two charges, which are separated by the distance r, separated by distance r, is directly proportional to product of the charges and inversely proportional to square of the distance between them. See, statement, what is the statement for Coulomb's law of electrostatics? The force of attraction or repulsion present between the two charges separated by a distance r or separated by some distance r, it is directly proportional to product of the charges, means product of this magnitude of these two charges, and inversely proportional to square of the distance between them. Inversely proportional to square of the distance between them. Then mathematically, how can I write this for law? That is, F is directly proportional to product of the charges, means Q1 into Q2, and inversely proportional to square of the distance between them. Square of the distance, that is, the distance is r, and square of that distance means it is inversely proportional to square of the distance between them. And we know, if I want to remove this proportional sign, I have to put one constant of proportionality, and that constant I am going to put as a k. That is, F is equal to k q1 q2 upon r square, where k is nothing but constant of proportionality. And that k is having value. What is the value of k? That is, k is equal to 1 upon 4 pi epsilon naught. 1 upon 4 pi epsilon naught. This epsilon term is new for you. What is this epsilon naught? It is permittivity of vacuum. Permittivity of vacuum. See, we have considered here that charges are placed in vacuum. Medium is vacuum. If another medium will be there, we have to put here in place of epsilon naught, we will put only epsilon. That is, or epsilon m. That is permittivity of that medium. Permittivity of that medium. What is mean by permittivity? See, in this chapter, next point, when we are considering electric field, in that we are going to study one term, that is electric field lines. Electric field lines is, these are the imaginary lines, like magnetic field lines you have considered in 10th chapter also. Magnetic field due to electric current means the effect of electric current. In that you have studied that solenoid and magnetic field lines, correct? Like that only, here also electric field line. So permittivity means the permission, permit, correct? Permittivity of that vacuum means ability of vacuum to permit or to allow to pass through the electric field lines through it. Means this permittivity of vacuum is nothing but the ability of vacuum to allow the electric field line or to pass the electric field line through it. Okay, so this is permittivity epsilon naught. And if I put this value of k in this formula, that is F is equal to, then I can write F is equal to 1 upon 4 pi epsilon naught. In place of k, I will put 1 upon 4 pi epsilon naught. And here there will be Q1, Q2 upon R square as it is. See, in this case also you have put that constant of proportionality as a G. See, F is equal to G M1 M2 upon R square. That G is constant of proportionality. Here K is constant of proportionality and having value 1 upon 4 pi epsilon naught. And value of this 1 upon 4 pi epsilon naught is 9 into 10 raised to 9. This is the constant factor. That is 9 into 10 raised to 9. Here there is a value of epsilon naught also. Permittivity of vacuum. What is that value? That value is 8.85 into 10 raised to minus 12. Here there is a unit for permittivity. To find out that unit, I have to take this epsilon naught towards the left side, correct? See, when we have to find, or if we want to find out unit of any quantity, we have to take that quantity on one side and all the remaining quantities on another side. Means we have to write the formula in that term, for which we have to find out the unit or dimensions, correct? So here F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. I want to find out the unit of this epsilon naught. So I will take this epsilon naught towards left and F towards right. So the formula will become, see, F is equal to, epsilon naught is equal to, because we have to find out the unit of epsilon naught. So epsilon naught is equal to 1 upon 4 pi F. F will be in the denominator. So 4 pi F. And here Q1 Q2 upon R square as it is. Therefore Q1 Q2 upon R square. Now what will be the unit? See, Q1 Q2, these are the charges. And what is the unit of charge? It is Coulomb. So Coulomb into Coulomb, that will be Coulomb square. Correct. And F, it is Newton. Force. Unit of force is Newton. And R is the distance. So what is the unit of distance? SI unit, it is meter. R square is there. Therefore, it will be meter square. Therefore, unit of epsilon naught or epsilon, simply permittivity. Unit of permittivity is nothing but Coulomb square per Newton meter square. Unit of permittivity, simply permittivity, not epsilon, not only epsilon. Permittivity, unit of permittivity will be Coulomb square per Newton meter square. Correct? You understood the unit? Okay, and what is the value of epsilon naught? Value of epsilon naught is nothing but 8.85 into 10 raised to minus 12. Then unit will be Coulomb square per Newton per meter square. So unit of epsilon naught will be Coulomb square per Newton per meter square, and value is 8.85 into 10 raised to minus 12. This is the value of permittivity of vacuum. As the medium will get changed, this epsilon value of permittivity will get changed. This value is for vacuum. This value is for vacuum. You understood the Coulomb's law of electrostatics? If it is asked for exam, it will be for 2 or 3 marks. In that case, they will ask the question as state and explain the Coulomb's law of electrostatics. First, you have to write the statement like this. Then draw this diagram. Only Q1, Q2 show the charges. Distance between them is R. Okay. Mathematically, we can write, say like this, and write F is directly proportional to Q1, Q2 upon R square. To remove the proportional sign, you are going to put the constant of proportionality. So F is equal to K Q1 Q2 upon R square, where you have to write K is constant of proportionality, and having value K is equal to 1 upon 4 pi epsilon naught. So again you have to mention what is epsilon naught. So epsilon naught will be the permittivity of vacuum, and formula will become F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, and 1 upon 4 pi epsilon naught, this is constant quantity and will having the value 9 into 10 raised to 9. It is a constant quantity, it doesn't having any unit. So it is 1 upon 4 pi epsilon naught is equal to 9 into 10 raised to 9 only. This is not needed to write in that question, because it is for you. You have to need, or you have to know this information, what is permittivity, what is its unit, and what will be the value, because they will ask directly what is permittivity. They will ask directly to state the unit of permittivity or to write the value of permittivity. So it is needed for that. But for this question, state and explain Coulomb's law of electrostatics, this is sufficient. Up to this, 1 upon 4 pi epsilon naught is equal to 9 into 10 raised to 9. Correct? You understood this explanation? Okay, if you like this video, like, share and subscribe my channel, and also press the bell icon so you will get the notification for next lectures or next videos. Okay, thank you.